Hello and welcome. So we have covered pretty much basics of IPv4. We have seen what its address space looks like. We have also covered how different protocols communicate using IPv4 and how they transfer information or networks information among one another. For example, we have covered OSPF and we have also covered EIGRP. But back in late 80s and early 90s, rather I would say late 80s, 1980s, the internet engineers, they had started to foresee this thing that the address space which is provided by IPv4, which is around 4.2 billion IP addresses, was not sufficient enough to cater for the future demands of internet. And as of today, we see that IPv4 has become depleted. It cannot cater for the demands of the world. Although it provides us 4.2 billion addresses, but considering that almost every developed country household has got at least one PC, one notebook, and at least 2 to 3 smartphones. So that will require at least 4 IP addresses, isn't it? So similarly, if we go down to developing countries, maybe this figure will not be 4, but it surely could be 2. So the exponential growth of internet, especially in this century, it has really put a dent on the availability of IPv4 addresses. In fact, in April 2011, I believe, April 2011, INA, which is the authority for managing IPv4 addresses, it allocated the last block of IPv4 addresses. And now if you go to INA and ask for a block of IPv4 address, they will give you a smile and say, well, we don't have it. And in fact, in return, they would ask you to get an IPv6 address. So IPv6 is pretty much here, and it also, besides giving us a better space, rather larger space of 128 bits, it has got some other benefits as well that we'll see in a while. So internet engineers, they started working on IPv6 as early as 1990s, and by the time of 1998, they were able to finalize the draft, which is now known as RFC 2460, which defines the basic features and functions of IPv6. In that RFC, we also see that it defines an address space of 128 bits. And since these are 128 bits, it's hard to write them in decimal or what to say about binary. So it gives us the provision that we can write these numbers, these IPv6 addresses, in form of hexadecimal numbers. And just to give you a quick overview of hexadecimal numbers, it's like hexa means 16. So binary means 2, which has got 2 states. Hexa means a numbering system which has got 16 states. Decimal means a numbering system which has got 10 states. So if I were to compare decimal with hexa, I would do it like this. 0 means, let's say this line over here is decimal and this one over here is hexadecimal. So 0 in decimal is equivalent to 0 in hexa. Similarly, up till 9, they are equal. And equal means not by virtue of their weight, rather just by the look of the numbers, they look the same. But in fact, their weights are different. And how they are different, I'll just let you know. And after that, when we go to decimal 10, then there is no 10 in hexadecimal. Rather, it's A. So 10 is equivalent to A, capital A, or it could be small as well in hexadecimal. Likewise, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. So if you count from 0 to F, these will be 16 states like I mentioned over here. So if I were to write like 10 in hexadecimal, it might look like that it's 10 in decimal, but it's not. And why? Because we need to convert it into decimal, and to do that, just like in binary we do, that we take the first least significant digit, multiply it with the base and raise it to the power of 0, plus take the next digit, multiply it with the base, which is 16, raise it to the power of 1. So once we do that, we see that this comes out to be 0 and this comes out to be 16. So 10 in hexadecimal means 16 of decimal. So they are not equal. They might seem equal as per the figure, but their weights are quite different. So it was just a quick overview of how hexadecimal number works and how you can convert them from decimal to binary, or from decimal to hexadecimal, or from hexadecimal to binary. Now, just like in IPv4 addresses, the IPv6 addresses are also controlled by INA, which delegates these IPv4 addresses to regional internet registries, which in turn delegates it to local internet registries or maybe ISPs. Now let's have a look at some of the benefits of IPv6 addresses. Now, besides having a larger address space, which is 128 bits, in IPv4 we had the concept of broadcast. Remember, we read about if we have a network, then every network has a network address and a broadcast address, remember? But in IPv6 protocol, there is no broadcast. Instead, and why there is no broadcast? Because broadcast has got its own cons, or I would say the negative aspects associated with it. Because if we have a network over here, and let's say that this node over here, this one A, wants to communicate only with the specific nodes among the network. Now IPv4 does support multicasting. It does support multicasting, but it doesn't have the native support for multicast. But IPv6, it has been designed in a way that multicast is an ingredient, or rather a native function of IPv6. Besides that, we also have a concept which is stateless address auto configuration. In IPv4, we have to use DHCP if we want our host to be configured dynamically. But in IPv6, we can use DHCP, which is called as DHCP version number 6. But besides that, we can also use SLAC, which is stateless address auto configuration, written over here, and it uses the protocol NDP, neighbor discovery protocol, and we'll read about it later. So let's just remember for a while that stateless address auto configuration, which uses NDP protocol, can be used to configure interface automatically and assign it IPv6 address. Also, IPv6 provides us native security feature using IPsec, IP security protocol. We can use IP security protocol in IPv4 architecture as well, but it hasn't got the native support in that we have to do some extra manual work to make it work with IPv4. And besides that, IPv4, though its header is bigger in size than IPv4, IPv6 header is bigger in size than IPv4, but it has got less fields. And in a while, we'll see what are the fields in there. Besides that, it also provides us the functionality of mobility. So if you have got one IP address, let's say in one country, by virtue of this mobility feature, that IP address you can take anywhere in the world and you can use it. It will stay unique and the ISPs or the service provider, they shouldn't have any problem that they cannot cater for this IP address. In IPv4 scenario, if you've got IPv4 address in one location or through one ISP, you cannot use that IPv4 address in another ISP. You have to change it, and you have, if you are running a server on that IPv4 address, you need to change the server IPv4 address, or whatever applications are using that IPv4 address, you have to tell those applications that now the IPv4 address has been changed. But in case of IPv6, that address may remain unique no matter where you go around the world. So let's quickly have a look at the IPv6 header, and look over here. These are the source and destination that we have just seen, that 128-bit addresses. And if you remember from IPv4, it had a field of type of service. If you remember that field is no more here. And also it had a field of header length. What is the length of the header? That is also not in there in IPv6. Then it had protocol field, which defines the upper layer protocol. Then there were flags field, and also fragmentation offset, and a couple of other that were also there, fragmentation offset field. So these all fields are not here. In fact, if you look at it, it's just got source, destination address, data, and hop limit, a flow label, and all these fields that were available in IPv4, most of them have been moved into next header field. And the reason is that network engineers really wanted to take the processing load off the network devices. And what it means that if we have a simpler header, because you see, routers or layer 3 devices, what they actually process, they actually make the decision of routing and the major portion of processing involved with the header. So if we make the header simpler, it would really ease the burden on these devices. So simpler the header, faster the processing. So that's one of the feature of IPv6, that making this header, though it's bigger in size, but most of these functionalities can be embedded in the hardware using ASIC circuits. So once they become simpler, it becomes quicker and easier for the routers to manage the data flow through the network. Now let's move on and quickly have a look at some of the protocols that need to be changed or maybe modified, or certain fees needed to be added to support IPv6. Now we know that if a host wants to communicate with another host on the same subnet, then it needs to use the ARP protocol to find its layer 2 address, right? But in IPv6, there is no ARP. In IPv6, there is neighbor discovery protocol. So the hosts, they use messages like neighbor solicitation and neighbor advertisement, these sort of messages, and we'll see about these messages in upcoming videos, that they use these messages to discover what are the hosts available on that subnet and then communicate with them. Likewise, routing information protocol, or RIP, or maybe RIP version 2 even, it does not support IPv6 addresses. So the protocol, it was modified in a way to support IPv6 addresses, and it is called as RIP next generation. Likewise, OSPF, the engineers had to develop OSPF version number 3. As is known as OSPF version number 2 supports up till IPv4, but OSPF version number 3 had to be developed to support IPv6. Similarly, EIGRP had to be modified into EIGRP, as we call as version number 6, to incorporate IPv6 addresses. And BGP, although it is quite flexible, it also needed some extension which is called as multi-protocol BGP to incorporate IPv6 addresses. Although there is one protocol, if you remember, I told you about it, ISIS, integrated systems to integrated systems, or maybe sometimes also called as intermediate systems or intermediate system. This protocol, since it was developed by ISO, and this protocol was not developed for IP networks, in fact was developed for telecom networks, and telecom addressing schemes were incorporated in this protocol. So this protocol has the support, rather I would call native support. We do not need to change anything in this protocol, that it supports IPv4 and IPv6. And that's the reason that many service providers use ISIS in their core networks. But since this is beyond the scope of CCNA, so I'll not be discussing about ISIS, but we have touched it that it uses the same link state advertisement mechanism to share the network topology. So that was just a quick overview of IPv6, and in the upcoming videos we'll see some more details about it. So stick around and I'll see you in there.